This is 4.5, Chapter 4, Word Problems, Part 2. This problem gives us a logistic growth function, and it tells us that it models the percentage, P of X, of Americans who are X years old and have some coronary heart disease. So X stands for the age of the person, and then P of X is the percentage of that age of people. It tells us to use this function to find the percentage of 56-year-olds, so that's the given information, who have some coronary heart disease. And it says find the percentage, so we know that we're looking for P of X, and they're giving us X, 56, right? So this one is literally just plug and chug. We're going to plug it in and then calculate it out. Okay, it tells us to round to one decimal place, so it would be 69.6%. All right, this exponential model describes the population of the indicated country A in millions. So population of indicated country A in millions, and then T is years after 2006. So which country has the greatest growth rate, and by what percentage is the population of that country increasing each year? So here what we're looking at is the exponent. T is years after 2006. I wrote that a little bit backwards, but years after 2006. And then the growth will be that decimal before T. And it's giving us a decimal, right? But it says that they're wanting to know the percentage. So for this first one, it would be 1.5%. I'm going to write the decimal out so you can see that. The second one would be 2.3%. The third one would be 0.6%. And this decimal came over two places to change it into a percent. And then the last one is actually decreasing. So when we compare all these percentages, we see that 2.3% is the greatest, so it's country 2. And it's increasing by 2.3% each year. So this problem is giving us some information. We're going to have to use that information to actually create the function, the growth function. It says in 2000, the population of a country was approximately 5.61 million. So 2000, it was 5.61 million. And then by 2040, it's projected to grow to 9 million. So they want us to use the exponential growth model in which T is the number of years after 2000 and A naught is in millions. Okay, so that's the population. And using that information, we're going to fill in that exponential growth model and then create one to use for later. I'm just rewriting the exponential growth function right here so that we can see as we fill in everything. All right, so remember that A naught is the beginning, right? So in the population, in regards to the population, it started at 5.6 and they said they expect it to go to 9. So it would be 9 equals 5.61 times E raised up to K. And then T is the number of years after 2000. So remember, (2040) would be after 2000. So they're saying, look, it's starting at 5.61 and then we travel up. So we're actually solving for K, which represents the growth rate. Remember in that last problem we looked at the value before, go back and look at it. We looked at the value before T, right? So whatever the coefficient was there, that was the growth rate. So that's what we're solving for here. Dividing both sides by 5.61 because I'm trying to isolate that E. Remember that once we isolate that E, I can take the natural log of both sides. I'm going to move a little bit to the left here. Okay, going to take the natural log of both sides. And then the moment that I do that, when I take the natural log of E, it's equivalent to whatever the exponent is, correct? So I'm going to go ahead and move it down here. We have natural log of 9 over 5.61. I'm not even going to try to simplify that and get some crazy decimal. I'm going to put 40K. It's standard that that coefficient goes first. And then I would divide both sides by 40. So in previous problems, we've done this where we were solving for T or an X in the exponent. It doesn't matter. Whatever variables in the exponent, if you have that base, sorry, that's really crowded. I'm going to rewrite it. So K equals natural log of 9. I need to erase that. That got too messy. Of 9 over 5.61 all over 40. Okay. I'm going to enter that in my calculator. I get 0.01181 and it keeps on going. It tells me to round to 2 decimal places. So K would be equal to 0.01. Okay, but that's just K, right? They want me to write the entire function. So remember, when I write the entire function, now I can fill in K, and I'm going to leave T blank and fill in everything else. So A equals 5.61 times E up to 0.01 T. And so that is the growth function that I would use for any other year as well, right? And that's what they do in the next question. They say, okay, well, the country's population will be 13 million. And so now they're giving me the population and they're asking in what year. So we're solving for T. So I'm going to bring that function down here. $13 million is my population. So plug in for A. And now I'm solving for T. Now this is different than part A because I was solving for K and I was able to put in T because they gave me the time or how many years passed after 2000, and they also gave me what the population was going to be in 2040. So I was able to solve for K. I have K now, right? Now they're telling me, look, the population will be this much, but what will the year be? So really understanding what they're asking you for is part of definitely the struggle of word problems, right? If you don't know what they're asking for, it's very challenging to even know where to start. Well, down here, I'm going to divide by 5.61 on each side. Okay, so over here, I have 13 divided by 5.61 equals e raised to 0.01 t. Because I have e as a base and I isolated it, I can take the natural log of both sides. By taking the natural log of e, it's going to be equivalent to the exponent and then to further isolate t, I'm going to divide by 0.01. So divide this entire side by 0.01. T equals natural log of 13 over 5.61. All of it, including the natural log, over 0.01. Let's plug that in the calculator. Okay, I get 84.0398, keeps going. Remember, this is a year we're talking about, and they do tell us to round to the nearest year. So 2084, because X is years after 2000. Here they're asking us to complete the table for the population growth model for a certain country. They give us the year and the population in millions, year and projected population in millions. And they want us to find the projected growth rate. So using that growth function that we were using before, and if you can't remember, just go to a question where it's given to you. And remember that A naught will be where we started, and then regular A will be where we end. So filling it in, we would first be in 2005, right? So 53.4 is where we started. 39.5 is where we end up. E is E. K I'm solving for, so K will stay K. And then T, well, that's going to be how much time passed from when we started. Well, we started in 2005, and now we're, the 39.5 million is for 2020, right? So how much time has passed? 15 years. Okay, so that's where we get that 15 from. I'm going to start isolating E. So divide by 53.4, divide by 53.4. I'm going to go ahead and write it 15K. Now we can take the natural log of both sides. So natural log of both sides. The reason that I do that is because when I take the natural log of E, it simplifies to whatever the exponent is. divide by 15, divide this entire side by 15, and I get k equals the natural log of 39.5 over 53.4. All of that divided by 15. We plug that into our calculator. We get negative 0.0201, yada, yada, it keeps going. It says round to 4 decimal places. So that takes me out to that 10201. Now notice that it's negative, and we're going to talk about that here in a second. Let me erase that so I can plug this in. So remember that K represents the growth rate. So coming back up to this one, right? We said that, okay, the coefficient up here is the growth rate. That K is the growth rate, growth rate. But in this last one, we said, okay, well, the growth rate is negative. So actually the population is descending, right? It's decreasing. Well, that is what this growth rate is telling us, right? Because it's negative. Now, when we look at the information, that makes sense. Because look, 53.4 in 2005. Well, if they're projecting that in 2020, in 15 years, it's going to drop down to 39.5, then that growth rate would have to be negative in order for that to happen. So just keep that in mind, and don't let that throw you when you're solving for growth rates if your K ends up being negative.